Hello! In this video I'll review another laser engraver, but this time a bit different one. It's my first fiber laser, Gweike G2. There are two versions of that laser, the one with manual lifting device and working area 110 by 110 mm, and the other version with electronic lifting device, which have working area of 150 by 150 mm. Plus there are accessories like protective shield, rotary chuck and rotary rollers. Here I have electric lift version and accessories into other box, so let's start with unboxing the G2 laser. When opening the box I firstly noticed the quality of box. It's definitely the strongest box I ever seen. Cardboard is very strong and more than 7 mm thick. Inside the box is a lot of protective sponge additionally wrapped into plastic bag. I think with all that sponge and strong box it's packed more than great and can handle any angry postman. Let's see now what we get into box. Power supply, accessory bag, cables, protective goggles, lifting stands and its part, and some more cables, elevation blocks, roller and of course laser with laser source unit. That's the content of laser box. Let's check a bit closer now. Firstly, I was impressed by the power supply choice. It's basic 24 volts 280 watt power supply, but it's industry grade brand. Meanwhile it's non-brand and their power supply is often used in industry, and that power supply isn't cheap. It has only 24 volt output but 6-pin connector, so it can handle the current, which is almost 12 amp, and of course there's also a Europe power cord. Here we have USB Type-C cable to supply lifting device, 20-pin cable for communication between laser and source unit, strong power cable which supply laser from source unit, and another surprise, branded USB cable with filters and golden connectors. Also that kind of U-green cables isn't that cheap. Protective goggles has its own case and cleaning towel, otherwise it's classic, totally same as we get with diode laser, except they has green protection. Into accessory bag we can find 10 pieces of anodized aluminium testing cards, 4 foam pads for laser base, some screws, 4 knobs, and 2 pieces holder with 6 plastic screws to set location on base for serial engrave. Here we have quality inox imperial and metric ruler, 2 plastic bracket for laser source with steel balls as wheels, 2 fully aluminium razor block with 2 different length knobs, laser holder plate. Electronic lifting device looks quite good. It's completely aluminium with 2 linear rails, brass bushing, end switches, touch buttons and so on. Base plate with lot of treats and removable center, with testing piece of paper from laser calibration. And of course here we have a laser galva unit, which weighs only about 1.6 kg, connected with a fiber cable to a laser source unit, which is a bit heavier, but entire laser with everything weighs just about 12 kg, so it's very portable. I didn't disassemble those units, so there isn't much to see. Everything is nicely closed into aluminium housing with a plastic handle. In front is an indicator light, from back side we got all the plugs like USB Type-B for PC connect, another indicator light, reset button, micro USB probably for setup, power plug, communication plug and USB Type-A for chuck and roller add-on. From the bottom it has mounting treat, lens, grooves to attach the protective shield, red laser for focus adjustment, some sensors and so on. If we remove the lens we can see a lot of electronics and the big galvo system inside. Now that unit is just lightweight, it's only small for 150 mm working area. I noticed that the lens is same as on manual version with focal length 210 mm, even if the electronic version has 261 mm focal point. Also on laser source unit isn't much to see, because it's hide into aluminium housing with lot of cooling fins and 4 powerful fans on left side. In front we got emergency button, which is also a laser head power switch, and laser source button. On top is a fancy steel handle, and from the back side it has 6-pin power supply connector, power connector and communication port for laser head unit, and USB Type-C to supply lifting device. I didn't tell any specifications yet, so here are some numbers. Laser has 20 watt of power and wavelength of 1064 nanometers. It has crazy speed of 15,000 mm per second and amazing repeat accuracy of 0.001 mm. Frequency range is from 30 to 60 kHz, but actually work from 20 to 60 kHz. Before assembly I take the USB drive, which is attached on the laser source unit, and prepare the PC. On USB drive we can find really great and clear English manual with every step how to set up for the result we want. Driver, G-Laser software, photos of calibration settings and calibration file. Assembling isn't big deal, just mount lifting device on base plate with 4 screws and attach connecting plate on with 2 nut knobs. Connecting plate has grooves, so we can set tilt laser from -45 to 45 degree. But there's one more hole and treat on connecting plate. It's for the grey aluminium knob with chamfer. If we install that knob, it will fix connecting plate on right angle, so the laser will be parallel to the bed. Then just mount the laser head on with blue aluminium knob. Now we need to plug all the cables, which is not a problem because there's only one way to plug them. Install the bracket on laser source unit and the laser is ready to work. It seemed a big mess with the cables, but few zip ties would solve the problem. Okay, now prepare the software. This is content of USB drive which come with the laser. Firstly install the driver, then open the software folder and find the G-Laser icon to run the software, which is bootable version, so there's no need to install them. But just download the entire folder on PC and start the program. If there's no machine connected, this message will appear, but we can still draw and prepare the files in offline mode. So plug the power supply and release the safety switch to turn on the laser. Plug the USB to PC and start the software again. I won't describe the software functions because it's easy to use and manuals are so good and basic functions are described into details. As you see, it looks familiar to other laser softwares. On top we have some toolbars, on left is drawing toolbar, on right side is marked parameter bar where we set the laser settings, and on the bottom is precize toolbar, where you also find the configuration button. And first thing we need to do is to click configuration button, so this window will appear. I had some issue with screen recorded files, so my laser is already calibrated here. Before calibration this number was all on 1000. I didn't calibrate into perfection, but just load calibration file, which is on USB drive. But if I remember, I need to add .cor on the end of unknown file. This numbers is also on photo, which is on drive, so we also can retype those numbers and should work the same. Let's just check the main settings. If we draw any shape or text and we want to engrave entire surface, not only the line, we need to click Fill button. And here we can find some settings like angle of engrave, cross fill and so on. But also can find the line field, where we set space between every line. And these settings have huge effect to power and time of engraving. Usually I set from 0.005 to 0.02 mm. After we have set up, don't forget to click Apply button. Then on right side set number of passes. Engraving speed I mostly use 1000 mm per second. Power of laser I set from 20 to 100%. And frequency, which mostly use 20 to 30 kHz, where the laser is most powerful. With higher frequency laser engrave better color, I think. Honestly, I didn't study all the settings yet. When everything is set up, I always click centering button, so it engraves in center of working area. Then prepare the piece you want to engrave and set focus, which is 211 or 261 mm, depend of type, from surface of engraved material to bottom of laser. But the G2 also has red laser to set up the focus, so simply hold the button for up or down until these two dots join together into one point. And that should be right distance. Works surprisingly well and makes setup so much easier. When the focus is set, click red button for framing, and laser will show the position of engrave with red laser. Now we have everything set up for engrave, but before hit mark button we need to power on the laser source unit. Otherwise we'll engrave all the same but without any effect. Then I imported the XF file of my logo and make a few engraves with different settings, and that was the moment I realized how fast the thing is. So far I only own diode lasers, so I was really impressed by that speed. You can see here some samples of my logo, dimensions 40 by 40 mm, engraved in just 1 second on 1000 mm per second and up to 8 seconds with 100 mm per second speed. Under the microscope we can see that engrave is super precise, no matter of unreal speed of 1000 mm per second. And also can see how thin the line is. On the bottom plate of inox is line made with diode laser, and on top is fiber. Now let's try to engrave some image. Engrave an image is a bit different than text or DXF file. When we import an image we have some settings on the left. Firstly set size, brightness and contrast. Then type how many dots per inch you want to have. More DPI mean better quality of engrave, since there are more dots in the picture mean better resolution. Usually I use 400 to 600 DPI. It's a hard work for software, so it may stop responding for a few seconds at this point, but never crash. We can see now our photo is made out of dots, so next settings is dotting time. That's basically a speed of engrave and mean how long each dot will be burned. Engraving an image is much slower than text or line engrave, but still super fast compared to diode laser. This logo is size 30 by 30 mm and was engraved in just 1 minute and 10 seconds. I think it makes a super result for such a fast engrave. Image look clear and sharp, while microscope reveal us all the dots. Diode laser engraved this image in 20 to 40 minutes, while G2 need just about 2 to 4 minutes for 40 mm size. I tried to engrave with different DPI settings, different dotting time, frequency and so on, and got some amazing result. Everything so far was engraved on inox sheet, and I noticed there are big differences depending on settings, so I tried to engrave different colors. I know you're all interested into settings, but there is so many things impact on color, so there's no sense. Best way is to make a test before engrave. I tried to engrave small squares with different settings like power, speed, frequency, number of passes, line per inch and one really important, focus. If we change focus distance for just a bit we can get very different result. You can see here many different shades of silver to brown and black, mostly depend on power and frequency. And on another plate I catch some really nice colors, like orange, violet, green, blue and so on. To get these colors just make tests, because a tiny difference make different colors. And all I can say is try with low power, more passes and higher frequency. Here are just some text engraving with different settings. When framing text or DXF files we can select to only show frame or entire line. Red laser is limited into software and only work with 3000 mm per second, but it's still so fast we can nicely see entire file. On first view is just a bit color difference, but if we look closer the details can be noticed, since I didn't change only the power and speed but also angle of fill, number of lines per inch and so on, and every little change affect on final result. G-Laser software also offer a few single line fonts, which is very useful for small engraves. Then I try how small can be engraved text that still be readable. Start with basic font 2 mm size and go down. On about 0.5 mm text is still readable, but 0.4 mm make a bit harder to read. So I switched to single line font where the text is still readable at 0.3 mm size, but I'm sure it can engrave smaller since I engrave with speed 1000 and 500 mm per second smaller text, so it engrave in 0.02 seconds, and I forgot to play with fine focus settings, which is quite important. But anyway, results are amazing if we compare with diode laser, which has limit on about 1 to 0.8 mm. You already see how fast the thing is, but just a few words about speed. Machine can work with amazingly 15,000 mm per second. When it make a speed test I only make 1000 mm per second and already can't believe its speed. Later I remember that it can do 15 times faster, so I try to engrave with max speed. Here I try some text engrave with 10 mm letter high, 1 pass, 100% power, 20 kHz. Start with 100 mm per second. Isn't that crazy? But let's check the results. I get some nice engrave on inox, especially with 100, 500 and 1000 mm per second. On 2000 mm per second engrave is still nice, but miss a bit of line on corners. On 5000 mm per second it starts engraving dots with missing tiny lines. Quite same result get with 10,000 mm per second. And also with 15,000 mm per second result is quite same, but need 10 passes to get effect on inox. Otherwise letters are incredibly good shape for that unnormal speed. I just can't imagine how fast the Galvo system is. G-Laser software also have speed frequency demo mode, and if I set to 15,000 mm per second and 20 kHz I got exactly the same result. So I tried to engrave one more time with 15,000 mm per second and 200 kHz. I think I actually work with max 60 kHz. And the dots was closer one to each other, but if we increase the frequency we will lose the power. So in reality I mostly engrave with 1000 mm per second, which is extremely fast and still make great engraves. If I need more power, just lower down the speed. What about fill speed? Let's check with 10 mm letters 1000 mm per second. Just line text need 0.4 seconds. If I apply fill with same settings it needs 16.3 seconds to engrave. And if I lower down lines per inch from 0.02 to 0.05 mm, it engraves in 7.3 seconds, which is more than twice as fast, and the result is even better if you ask me. And if we go into configuration, tab red, we can also set framing red light speed, which is set to 3000 mm per second and allow us to rise up to 10,000 mm per second. There is a difference, but Galvo become louder, so I set back to 3000. Okay, let's try to engrave different materials now. I start with anodized aluminum cards which come with a laser. Anodized aluminum can be engraved with low power and high speed, and the result will still be clear. Just look at that speed. Isn't that crazy? So I tried to engrave a grayscale image with fast settings, and the result was still amazing. That image is just about 10 mm wide. And also logo is clearly visible, but you can notice unengraved spots between lines. That means focus wasn't set good enough. Then I tried to engrave on raw steel, which engraved really nicely. With different settings we can just mark on surface or make a deep engrave. And also on steel can get a few different colors. It makes really nice engraves on chrome tools. Oh yes, before you ask, yes, I tried to clean the rust, and that's the results. It removes rust nicely and fast, but the surface is still rough. Raw aluminium engrave easily, and also can be deep engraved. Carbon fiber plate can be engraved with low power, so it won't melt too deep. And also on rubber got some nice result without burning surface like laser diode do. On brass we can make different colors engraved from black to white, and also deep engrave is possible. Acrylic or plexiglass I have can't be engraved, same as on diode laser, only work on black color, but I got some amazing results, so the engrave is lifted up from surface. "3D printed PLA can't be engraved, maybe some darker color will work, but nicely engraved different plastic, just need to set up without fill, otherwise material heat up and make a mess. Make really nice result on powder paint, super fast with low power. Fiber Laser have no effect on wood at all, but got some nice engrave on leather in different colors and types of engrave. On tiles and ceramic it make much better and clear engrave like diode laser. With some settings it make engrave with melted glossy surface. Also on stamp rubber engrave much more precisely with sharp edges than diode laser and do it much faster. Got no luck on gloss surface even if I try with different paints, but I'm sure there are better techniques and settings to make it better. And on copper it only make visible engrave, until I figure it out that copper engrave better with a bit lower focus, so I tried to make a PCB. But middle material didn't hold the heat and it burned before copper layer was engraved, but it still may work with different settings and maybe cooling of material. And of course I need to try this satisfying engrave of electronic components. Now let's try some cutting and deep engraving. Firstly, I try to cut thin aluminium plates which come with machine, and it cut through faster as I think. It only needs about 20 to 30 passes. 0.8mm raw aluminium without problem, just need to set many passes. And then I try to cut 1.5mm anodized aluminium plate. Actually it cut through, but need to set wider line to engrave and change the focus few times during cutting. Also cut is not the best, but just want to test the laser limits. Then I tried to cut also 0.4mm inox, but had no luck here. So I make a few more deep engrave. Into aluminium we can go about 1.5mm deep, and the results are quite good I think, while into steel limit is about 0.5 to 1mm max. That's it about materials. After all, I can say Fiber Laser work on wide range of different materials, and with different settings we can get very different engraves. And now it's about time to unbox the other package, where I found 3 boxes with protective shield, rotary chuck and rotary rollers add-ons. Let's start with protective shield. It's packed well and come in 2 pieces, because its height is 210mm, which is just the focal distance of laser with smaller working area and manual lift. This version of laser got focal distance of 261mm, so there's an extension of protective shield we need to screw on. There's also a bag with screw and tools with the shield. To assembly, simply slide shield into extension and gently tight a few screws around. After assembly, protective shield is about 160mm wide at the bottom and exactly 261 height, which is the focal distance of laser. On back side of shield is a small fan which provides clean air inside of shield. To mount the shield, just take off the laser from the stand, remove lens protective cap, put on the shield and slide it into grooves. When shield is attached, just plug the micro USB cable on back side of galva unit. Protective shields also have 2 magnets on top, which is on same locations as some kind of sensor or switches on galva unit, but I don't know their functions as I didn't notice any change here with or without protective shield. Okay, now we have portable laser engraver. With using protective shield we can engrave just wherever we want. Focal distance is right on the end of shield, so we just push and hold the laser wherever we want and start engraving. This is very useful add-on to engrave almost anywhere in any position. Let's check the rotary rollers now. It's packed well in a box with foam insert. First thing I notice is how small the thing is. It's only about 153mm long, 90mm wide and 36mm height. It's completely aluminium except the plastic belt cover, and if I remove them we can see the 3 pulleys connected with a belt and a belt tensioner. It looks quite strong and quality made, especially rollers are amazing. I don't know if they're made out of aluminium or some very strong plastic, but surface pattern is amazing, since it grip very well on any surface. To install, just put the rollers on laser table on X or Y directions and plug the USB cable in galva unit. Then put on the round piece we want to engrave and set the focus on top of that piece and we're ready to go. Now set up the software. I know that rollers can be very hard to set up, but not here. Manual describes just every step what and how to set up. Firstly insert file, text or whatever and set base settings. Then click movement axis tab and split mark, so this window will appear. Now click config button, select rollers and set number of pulses to 1600. Everything is so clearly described into manual, so just follow them and everything will work in a first try. Then just click right to frame and positioning and then mark. Almost can't believe, but it actually worked in a first try. If the piece isn't perfect round, there will be errors on engraves due to moving of engraved part while rotating. But we can make this fault less visible. With movement number we set how many splits we want. Laser will engrave between the lines and then turn. So if we want to engrave smaller diameter we need more splits. And we can also adjust splits manually between letters, for example, so the errors isn't that visible. So we can set one split 10mm wide and other only 1mm, just as we want. At that point I reach the limit of lifting device, so I need to insert lifting block. We can insert one or both lifting block, just need to use right screw. By this we can lift laser unit for about 10 cm. While using the rollers, diameter of piece doesn't matter. I make a test with different diameters and always get precise engrave. Then I make a few more tests and get some nice round engraves without any complicated setup. Rollers run very smooth without any vibrations and have amazing grip. Also glass doesn't slip at all, but we can still use some rubber rings just in case. On rollers we can engrave round pieces from about 1mm up to 100mm diameter with using boot lifting blocks on a laser stand. For bigger diameters we can tilt the laser unit and put rollers on some lower position and use protective shield to get right focus easier. Now let's check the rotary chuck. Also this one is good packed and protected. Into box we got completely pre-assembled rotary chuck and back with tools and accessories. Rotary chuck may look small, but it's very heavy since it's completely metal. It has aluminium frame which got tilting function from 0 to 45 degree and 2 knobs to lock the setted angle. Into middle of frame is a stepper motor with a flange and heavy chuck on it. It's a 3-jaw self-tightening chuck. There's a spring on back side which holds the jaws tightened. Into accessory bag we find 4 different clamping pins and a softer spring for chuck. Each jaw had 5 holes, so we can screw clamping pins just in diameter we need. Bore into chuck is about 30mm deep and about 23mm diameter. Clamping capacity is from about 1mm between jaws and maximum about 80mm with clamping pins on last position. With this chuck we can also clamp from inside. To do that, simply take some pin or any M4 screw and screw it into spring pin. Pull it out and turn the spring on other side. Put pin in same hole and that's it. The jaws now forced into open position. So it offers us to clamp different diameters inside or outside. Clamping is very quickly, but may be a bit annoying sometimes due to a spring. And I notice on bigger, larger and not perfectly round pieces also strong spring can hold the piece centered. But that's exactly why we have rotary rollers. I think chuck is more commonly used in small pieces and internal engraving, like rings and so on. Now put the rotary chuck on base plate on X or Y direction and plug the USB cable to galvo unit. Into software prepare file or text, then go to moment axis and split mark. Then click config button, choose chuck and set number of pulses to 3200. And if you want to engrave inside, you'll need to reverse rotary axis. Click OK and then select which side you want to extend, X or Y. Select moves or manual split the lines and then set very important settings, diameter of working piece. On rollers that settings doesn't matter, but on chuck is very important. And that's all we need to set up. Now just click red for preview and mark to engrave, but don't forget to set laser settings before. When I make a first try, I noticed that the chuck changing its position because of quite fast turning of heavy chuck. But a piece of fabric between base plate and the chuck plate make a huge difference. Some rubber pads or double-sided tape fix it even better. Now set focus on center of working piece, set laser parameter and start engrave. I make a few tests with different settings. Start with 0.5mm splits and then same engrave with 5mm splits. We can see that engrave with 5mm split is much better, but also have bigger errors exactly at the split point. So I try again with 0.1mm splits and then again with 5mm splits, manually set it between each letter, and that's what I get. Engrave with many splits is quite good, but make rough surface, and to engrave it need 25 seconds. While same engrave splitted between each 5mm letter need only 5 seconds, and engrave is perfect. While engraving text, splits between each letter is some kind of must to eliminate shifted errors, except if we got perfectly round piece clamped into perfect center. Also, image or DXF files isn't problem to engrave on round pieces. Then I play a bit more. It make a beautiful engrave on chromed brass. When engraved inside of rings, still chuck just as it need, so there's minimal difference in focus. And make a test before, because here we need to play with mirroring text and reverse chuck rotation. Then I mark some of my tools, like this fly cutter for example, and always want to mark drills. I know I am not the only one who hates these tiny marks on end mills, so I engrave its diameter a bit bigger so you can clearly see its dimension. Some plastic engraver, and you can see what happened if we set wrong piece diameter, and some chamfer engrave. That's it about rotary add-ons. I was impressed by how simple it is to set up rollers or chuck, and I think I got some really nice round engraves. I know this video will become way too long, but there are so many things to tell. One more is tilting option. When we want to engrave on angled surface, simply remove the centering knob and release other two knobs on a laser holder, so you can freely set the laser angle from -45 to 45 degrees. Finding right focal distance is a bit tricky, but much easier if you use protective shield for reference. And if you want to engrave bigger object which can be fit on base plate, we have two options. First is to remove the laser from stand and use protective shield, and second is to remove middle plate from base plate and just put entire stand anywhere to engrave. There's another thing I forgot to mention. Glaser also has Wi-Fi and its own mobile app. Into Google Store we can find it as Glaser app. Also, this topic is covered in manual step by step, so installation and connecting isn't a big deal. App worked nice without any issue, and offer us to engrave photos from phone, take photos, text engrave, samples engrave, and so on. It may be useful for some quick engrave, but honestly I need a keyboard and a mouse to work comfortably. Okay, I'm so excited about that machine I could just talk and talk, but video is already way too long, so it's about time for conclusion. I can honestly say I really enjoy testing this laser. I make many hours during this test and I always see new capabilities of use. So far I only use diode laser, so this G2 fiber laser is definitely a next level tool. Because with diode lasers we are pretty much limited on wooden surface, but fiber laser works on so many useful materials and it's extremely fast. This laser will definitely get its own place in my workshop. I was looking for some fiber laser for a while, but the prices was over 5 kilo not so far ago, so I think Glaser make a great job here when deliver a fiber laser for the price of better diode laser. I still hardly believe what we get for that price. There are many things I like on that machine, and detailed instructions is definitely one of them. Everything is so simple to set up and everything work out of the box, also rotary add-ons, which is really amazing. The only cons I found is actually a loud cooling fans on laser source unit. When we turn on the source power, fans instantly start turning with full speed, and yes, they're loud. I miss a temperature controlled fan driver here, if even necessary, because after a few hours of engrave at full power source units stay completely cool, while galva unit become a bit warm, but I would say about 35 degrees Celsius max. At that point I just want to warn you to be careful while making deep engrave or cutting. There are a lot of metal dust in the air. Best way is to use ventilation for sure, otherwise use protection equipment, especially respiratory mask. You can trust me, I know what I'm talking, because I had full throat of metal taste for days. And also my laptop wasn't immune to the steel dust, which make a short to magnesium housing, but luckily just a few components was burnt, so laptop is back to life. And that's about it. I think it's an amazing machine for the price, which offers us so many options to engrave different materials and shapes. I see a lot of potential in that machine for some small business to engrave cards, dog tags, making stamps and a lot more. So check below in the video description for the link to get more details, price and maybe make an order. I hope you get some useful information you was looking for. Thanks for watching, like, share, subscribe if you like, and see you next time.